Hello everybody, today we are going to do section 10.2, solving square root equations. A square root equation, by definition, is any equation that contains a square root with a variable in the radicand. Again, the radicand is what's inside the square root symbol, so we're going to have a variable inside the square root symbol that we're going to need to solve for. Alright, so we have our first example, square root of x is equal to 6. Now when we solve an equation, remember we want to do the inverse operations to both sides of the equation to keep it balanced. So we have a square root on the left side. Well, what is the inverse or opposite of a square root? Well, it's actually a square. So what you're going to do is you are going to square this side, and you're going to square that side. And what happens is when you square a square root, the two cancel each other out, leaving us with just x on the left-hand side. And in this problem, all I have to do on the right-hand side is to square 6. 6 squared is 36, and that's the answer. If we go back to check our work, the square root of 36 is 6, so we know that we got it right. Number 2. Again, we have our square root on the left-hand side and just a number on the right-hand side, but inside our square root symbol is a variable. So what we have to do is we have to get rid of the square root. So what we do is we do the inverse or opposite, which is squaring. And we're going to square both sides. And again, what happens over here is the square root and the square cancel each other out. And I'm left with x plus 13. And on the right-hand side, I have to square 7, which is 49. And now I would solve it like a regular equation. I'll subtract 13 to both sides. And x is going to equal 36. And again, if I were to plug this back in to check my work, 36 plus 13 is 49. The square root of 49 is 7. Why don't you pause the video and go ahead and try number 3. Alright, I got 71. Hopefully you got the same thing. And if I go to plug that back in to check, 2 times 71 is 142, plus 2 is 144. The square root of 144 is 12. So that's how I know I got it correct. Alright, now we got a new set of problems. We have a square root, and we have some operation happening outside of the square root. We had this happen to us earlier in the year when we were doing absolute value equations, where we basically have to isolate the square root before we can get rid of it. So what we're going to do is we're going to basically solve for the square root first. So I'm going to get rid of this negative 7, and I do that by adding 7 to both sides. And that gives me the square root of x is equal to 10. Now it's like the problems from earlier on. I want to get rid of the square root, so the opposite is squaring. And those cancel out, leaving me with x. 10 squared is 100. Again, check my work. Square root of 100 is 10. 10 minus 7 is 3. I know I got it correct. On this one, I need to get rid of the 1. Now remember, the 1 is positive here, so I'm going to do minus 1 to both sides. And get negative root of x is equal to negative 3. Again, I'm not completely isolated because I do have this negative. So I'm going to divide both sides by negative 1. And I'm going to get square root of x is equal to 3. And the opposite of square rooting is squaring. And that gives me x. Oh, let me erase that. Gives me x equals 9. Go ahead and plug that in. Square root of 9 is 3. 1 minus 3 is negative 2. I got it correct. Go ahead and pause the video and please work on problems 6, 7, and 8 so then I can check your work. All right, for number 6, I got x is 12. For number 7, x is 10. And number 8, x equals 14. Hopefully you got all 3 of those correct. If not, certainly pause the video and go back to the problem so you can see my work. All right, number 9 is a little different. Number 9 has a square root on both sides. Again, the process is the same. We need to get rid of those square root symbols. So what I'm going to do is I'm going to square this side and square this side. This is actually a very easy problem to solve, because what will happen is, again, when you are squaring and square rooting, they're going to cancel each other out. So this problem is 3x plus 1 equals 4x minus 7. And then we solve it. So I'm going to take away 3x's from this side and get 1 equals x minus 7. Add 7 to that side and this side, and I get x equals 8. In the checking, 3x plus 1, so 3 times 8 plus 1 is 25. Square root of 25 is 5. On the right-hand side, 4 times 8 is 32. 32 minus 7 is 25. Square root of 25 is 5. They match, which means I got the answer correct. Please pause the video and try number 10. Alright, and for this one I got x equals 5. Hopefully you did as well, and it does indeed check. Alright, so the last part we're going to talk about today is this thing called an extraneous solution. It says squaring each side of an equation can sometimes introduce a solution that is not a solution of the original equation. The solution is called an extraneous solution. Extraneous solution. Basically what that means is it's impossible for it to work. Like it works itself out in the equation, but in real life the answer cannot be that number. Just like earlier we talked about, if you got a side of a triangle that's negative, that's not possible, so it can't work. The same thing is going to happen here. We just call those extraneous solutions. So let's try this one. I have x equals the square root of x plus 6. In this time, I'm going to try to get rid of the square root symbol, so I'm going to square both sides. And when I do that, I get x squared equals x plus 6. So I see a squared variable. When we're solving an equation with squared variables, hopefully you remember from chapter 7, that means we need to factor. So I need to bring everything over to the left-hand side so that my equation sets equal to 0. And this is going to give me x squared minus x minus 6 equals 0. And I'm looking at the method I can use, and it's going to be product sum. So I'm looking for two numbers that multiply, that give me -6, but also add to give me -1. So I'm thinking it's going to be x minus 3 and x plus 2. That equals 0. And that means the answer to my equation, again, is anything that would make that 0. So x is going to equal either, in a solution set, -2 or +3. Now I need to make sure that these are actually viable answers. So if I plug this back in, if I say that x is -2, in the square root, -2 plus 6 is +4, and the square root of +4 is 2. I do -2 over here, and -2 can't be the answer, because when I square rooted the right-hand side, I got +2. It does not equal -2, so -2 is what we call an extraneous solution. Let's try 3. 3 plus 6 is 9. The square root of 9 is 3. and x on the other side is 3. That one works, so our only possible answer here is positive 3. All right, I want to show you this again. For this problem, we have square root of 4x plus 5, and that is going to equal x. So again, what I'm going to do here is I am going to square both sides to get rid of the square root, and I get 4x plus 5 is equal to x squared. And again, what I have here is I have a squared variable, which means I have to factor. So setting everything equal to 0, I'm going to get x squared minus 4x minus 5. And the method for factoring here is going to be product sum. So I'm looking for two numbers that multiply to give me negative 5 and add to negative 4. So that's going to be negative 5 and positive 1. And my solutions will be positive 5 or negative 1. But what I now have to do is I now have to check and make sure that that works. So I'm going to try 5 first. 4 times 5 is 20. 20 plus 5 is 25. The square root of 25 is 5. X does equal 5. That one works. Let's try negative 1. 4 times negative 1 is negative 4. Negative 4 plus 5 is positive 1. The square root of 1 is 1. So it didn't work because we got negative 1 as our answer, but it would need to be 1. So negative 1 is an extraneous solution. The answer to this problem is positive 5. All right, number 13. Again, same concept here. I'm going to square both sides. And I'm going to get x plus 14 equals. Now when I square this side, it's a binomial. Remember, in a binomial you have to multiply the binomial times itself. But when we square it, that is a special product. So hopefully you remember special products from chapter 7, where we're going to get x squared and then the 2 times what you get when you multiply them, which would be 4x's and 4. And again, I see a squared variable, which means I have to factor and make one side equal 0. So this is going to equal 0. And I get x squared. 4x minus x is 3x. And 4 minus 14 is going to give me negative 10. So again, I'm going to factor. It's going to be product sum again. And I need two numbers that multiply to make negative 10 and add to positive 3. So I'm thinking it's going to be positive 5 and negative 2, which gives me my possible answers of negative 5 or positive 2. And then I have to check my work. So if I do put in negative 5, negative 5 plus 14 is 9. Square root of 9 is 3. Other side, negative 5 plus 2 is negative 3. Negative 5 does not work. That is an extraneous solution. If I plug in 2, 2 plus 14 is 16. Square root of 16 is 4. 2 plus 2 on the other side is 4. 2 works. 2 is the answer to the problem. Please pause the video and do number 14. All right, so hopefully you got the answer of 2. When you factored it, you got negative 4 and positive 2, but negative 4 is an extraneous solution. Again, the big idea here is always go back and plug it in and check your work, because when you check your work, some answers may not actually work in the problem. All right, that's it for today. I hope this finds you well, and you can work on the problems that I have assigned for you. I'll talk to you tomorrow.